record button on my end.
Okay.
All right.
Okay. We're set and recording.
Yeah, set recording. Okay. All right. So let's see. Everybody hearing our rambling and all that up from over there?
Loud and clear.
All right. Thank you. Well, welcome to the February meeting of the Seattle Robotics Society. As you perhaps, if you figured it out, Lloyd and I are actually sitting in the same room. Just so happens that I am in blur him out now. He's concerned about you seeing his head. So, my wife and I were traveling over here to visit my sons in Seattle, and so happened to be over here over this weekend. So I said, well, we decided let's get together and we'll do the meeting from your place. So you're getting both of us from the same place, and Lloyd will be doing the presentation later today. So, let's see here. I need to be able to see. Oops, where is it there? Okay. Let's see. You know what? I need to be able to see that. So I'm going to switch over to here. All right. Get this guy out of the way. I'm doing this with a single monitor today, which makes it a little bit weird for me, but that's all right. Okay. All right. So if you make sure that your microphones are muted if you are, unless you're actively participating, or sharing.
I almost muted my microphone, which was bad.
Yeah, it's a habit, right? And then, of course, Lloyd is already aware of this, but of course, for presentations, please don't. And actually for general sharing, just don't share anything that's proprietary, because this is going to go out on YouTube, so the entire world will be able to listen to this and watch it forever. So, we got a little bit of a change up in our agenda today. We will most of these items are probably things that we've had in past meetings, but we are going to include a new section that we call Tech Ed topic video and discussion. So that will be done in conjunction with the around the room, and the goal is to just sort of bring back some of that, some of the original sharing of just how to do things. And anybody and everybody that has ideas or suggestions for what they'd like to see here can chime in, because the goal of this is just to make an interesting section to the meeting for people that have been here for a long time, as well as for newbies. So we'll talk a little bit more about that later. We now have a Discord server. So if you go to the community page of the SRS homepage, there's the left side talks about the Discord server and getting onto that, and the right side is the email server. So if you haven't got that set up, please do it. Merch store. If you want to get SRS logos or images on pretty much anything you can imagine, you can go onto this website, and these guys can probably do it for you. And if there's any SRS graphics that you can think of that you'd like to see in the store and available to put on stuff, let us know via the SRS email, and we'll see if we can get that taken care of. In this next week next Saturday is the last Saturday of the month, and so that's when Donna does the Build It with Arduino meetup group. So she'll be hosting that from 1 to 3 Pacific time, and so it's a great opportunity to just learn how to do stuff with Arduinos or be able to share stuff. And I encourage people that do work with Arduinos and know them reasonably well to participate in that, and just help out with sharing what you know, and helping other people to be able to join that, jump on that bandwagon. So, and let's see, with coming events, there's a couple of websites here. Oh, I didn't take the L and the R. I guess I should have taken those out of there. Oh well. I used to have a couple of barcodes or QR codes in there that you could scan. But the Robot Events website, it seemed the Robot Events website, it seems like is mostly VEX stuff. That seems to be lots of VEX activity. So those are a kind of a cool erector set style of robot that can be done with in a competitive environment. And then of course Sunoco Makerspace is say Chaz, are those still weekly? Are those still happening weekly up there?
Yeah, just for an open house, they happen Thursday nights at 6 Pacific.
Okay.
And then there's we have a robotics in-person meeting. It's not on Zoom, so you need to show up. But it's the first Saturday of the month, so
Saturdays.
you want
Okay.
to get robotics twice a month.
Yeah. Okay. So there's a good opportunity. So if you caught that, so you can get first Saturdays, you can do Sunoco Makerspace, but you got to go there in person. So unfortunately, sorry for those of you who are not locals, which includes me. Third Saturday is this meeting, and then the last Saturday is building with Arduino. So lots of opportunities to do robotic stuff.
Mhm.
And let's see, anything that anybody has watched or been to here in the last recently they wanted to share about?
I've actually got one.
Okay.
So Linux Fest Northwest is coming up April 24th to 26th at Bellingham Technical College. It's a free little Linux convention. Both my wife and I have gone to it for probably about the last 10 years. It's pretty lightweight and fun. So if you're in the Bellingham area and want to go, it's April 24th to the 26th. So and it's good for all technical levels. There's usually a couple of really good technical talks I get into, and there's also stuff my wife gets into. So it's pretty diverse.
What does your wife do?
Huh?
She does tech talks?
No, no, not she doesn't do the technical talks, but she'll attend. There'll be some like introductions to using GIMP or Blender or something like that, or using LibreOffice or one of the Office suites or something.
Okay.
So there's kind of intro talks there too that she gets into. So
Cool.
yeah, it's a really well-rounded free event,
Wow.
right? And it gives us a good excuse to drive up to Bellingham and stop in and get a burger at Boomer's, and we've got our habits.
If it wasn't a 700-mile drive from Boise, I might take you up on that.
I think there's a train station that'll take you there.
There's also the Sparks Museum.
Yes.
Oh, yes.
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 We've done that too, and that is quite cool.
Yeah, they used to, in fact, at the college up there, they used to have a fairly active robotics group. I'm not sure if that's still going. I don't know if anybody knows or not, but yeah.
They moved their makerspace to the mall.
Oh,
But
okay.
it's still active.
Okay.
Okay. And I've been through that makerspace, and it's a nice makerspace too.
Agreed.
Mm. Cool. All right. Thank you. Anything else?
Okay, so has anybody else seen the Kung Fu robots? Well, this is no laughing matter.
Oh,
Go to
Oh, come on, we'll laugh at anything.
well, go to YouTube and look up Kung Fu robots, and you will find what is it? It's close to a dozen robots doing Kung Fu, and it's not what do you call it? It's autonomous, and it's from China.
uh-huh.
See if you can find that. I've got it on my phone here, but I don't know how to get the URL to you.
Let's see.
So
I
yeah,
saw that yesterday, and it is very, very impressive. It's a testament to pretty amazing motors and tight control systems, and a lot of good training data on how to do it. I will point out that we look at it and we go, "Oh wow, that's really hard to do and really impressive that the robot can do it." But in fact, the truth of the matter is that or low energy stable walking gait is actually much, 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 much harder. And we think it's easy because like we do it effortlessly, right?
Right.
But those are, I mean, the Kung Fu thing is, it's cool and it's amazing. I don't want to take away from it. It's pretty wild demo and it's real. I've seen control systems from guys that I know, and I know they're not lying. It's actually doing that. It's not teleoperated. It's not whatever, but I mean, it's effectively a recording. It's trained into a neural network, right? It's not an actual like hard recording, but what it is the neural network has learned that if your joints are in this position and you're feeling these forces and your IMU is saying this, then you should move this motor by this amount of distance, right? So it's like it in the same way that the human body would learn through muscle memory. It's mostly muscle memory, right? But it's not. The actual impressive thing is the robots that can walk long distances at a steady pace on a single battery charge, right? That's the stuff that's actually hard to do. People don't see that, so I just wanted to make that comment.
But this is many robots and many humans in close proximity doing things like Kung Fu.
Okay, well, that sounds like something worth looking into. I have to dig those up. All right, anybody else? All right, we'll jump into we'll go on to the next one. Open discussion topics. I'm planning on doing an open discussion next month, and let's see, what did I call it? It's come out. The title's coming up here, but it has to do with why have robots in our lives, and this is a presentation. This was a discussion that we had about. It was before we started recording, so it's probably back in 2018, 2017, 2018, somewhere back there. And so I'm looking at that, pulled up. I actually had the slide deck for it, so I was looking through that and going, yeah, okay, now I'll just update this thing a little bit, and we'll run it and get a recording of it this time. And it had just kind of lots of good things about why do we build robots, and why is this, why does it fascinate us so much? So so we'll join us for that next month. And there's, of course, lots of other possibilities here. Generally I try to get live presenters, but if not, then we can use these discussion topics to fill in gaps. And I have lots and lots of options. So I'm not even gonna ask for solicitations because I have many ones to follow up on here. So, but I do appreciate anything that you do. If you do come across something that you think like this would be really cool, well, don't please send it to me. Don't hesitate to send that. So, why have robots in our lives? So, anyway, I think you'll enjoy it. So, coming up, I forgot to take Craig off of there. Yeah, on his autonomous mower and Scotch broom puller. Usually I take last month's off of there. So Lloyd is going to be talking about choosing the right programming language here later on today, and so we'll do our round the web, round the room, and our tech ed moment, and then we'll do a short break, and then we'll do the presentation. So and then Lloyd will be talking about the free C++ static analysis tools in April. And I don't remember now if I'm going to be. I'm not, you might have to take that meeting for me, Lloyd. I mean,
okay.
Yeah.
I'm here, so that'll work.
Oh, good. Okay, so there's a slide that's coming up for Lloyd, and let's see, Robothon update. So I think I've got the information.
Yep, that looks right.
Okay, so anybody have any questions or comments about the contest lineup that we have planned here?
Yeah, and just one comment on Robothon. You've got pretty much all there. The mini sumo you can move to autonomous, but that's the same contest. But this will also be. It's going to be in Seattle. It's going to be at Punk Rock Flea Market, which is kind of a It's a different venue than we've ever done before. But the key reason we're doing this is we are also pairing up with WAR. So Western Allied Robotics will be there, kind of like we had back at the Seattle Center. So we'll be doing it in parallel with them. So this should be a little bigger event than we've done for the last few years. So it should be good. And it's in August.
So where is the flea market?
Capitol Hill area. Do you know where Ada Books are? Or
Yeah.
is?
Oh, yeah.
Down in that area.
Okay.
We'll get the if you go to the robothon.org website, the address is there. It's 42. Tell you what, I'll just put it in the chat.
It's also only a couple blocks away from the train station. If you don't, there's not a lot of parking in the area, so you might want to take the train if you're up for that.
That's a good option too. Yeah, it's if you look at the place, if you look the place up and look at it on Google Maps, you can see that it is definitely very limited parking. Did that used to be a grocery store or something
Yes.
back in the day? Yeah.
My understanding.
Okay.
But the building itself is pretty good size, but they just, well, probably because of the value of real estate up there is so ridiculous. You know, parking lot is almost considered wasted space, I think. So
Yeah. And
Yeah.
okay, I did put the address in the chat, and there will also be a noontime presentation, I believe, on 3 kilogram sumo again.
Oh yeah, yeah. I think Donna Smith is going to be
Yep.
talking about that. So, yeah. So there's interest in bringing back the 3 kilogram class of mini sumo, autonomous mini sumo, and or sumo, and you get, you know, when you get above the mini class, the 500 gram, you can get into the size of your batteries and motors allow you to make much more aggressive sumo robots than you can on the small scale. So I remember that was always quite entertaining, you know, because you know, robots like that. And remember Bill Harrison? Some of you have been around long enough. You might remember Bill Harrison. He was very deep into those things, including the vacuum ones. He was even thinking about having ones with vacuum that could do the sumo stuff on the wall.
Oh, geez.
Yeah. Yeah. Just try to imagine that, or possibly the ceiling, you know. Yeah. I mean, it's kind of crazy. And then also magnets too. The high energy magnets. And oh my goodness. He was into all of the extremes of that type of robot. And he made some amazing robots. And but not a lot of people had the audacity, you might say, to go and build machines like that. But he did. Okay. So a little bit more about the monthly Tech Ed topic here. So what I'm going to do is I'm looking for probably short, typically 10 to 15 minute ish videos that we'll share technical topics, and we're going to just include those as something that just shares information and knowledge. Probably maybe somewhat more practically. Some of the presentations that we have, I know, I hope they're interesting to you. The presenters that we get, some of them may be a kind of beyond what you might be able to do yourself. So, looking at bringing something that is going to show you or introduce you to things that you can do that are kind of down at more of a hobbyist level. And so the video we're going to be watching today is just going to be about these multi-packs of robot sensors that you can go on Amazon or any of the variety of places out there on the web, and you can buy these basically a bag full of parts, and the sensors might have digital or analog outputs, and you can pretty easily interface these things to any processor that has digital inputs or outputs and an analog inputs or outputs. And so we're going to just kind of go through some of those sorts of things. And if you have other ideas or videos that you would like to suggest, look for videos that are on the order of 10 to 15 minutes max. Don't want this thing to stretch out for too long because we want to have some time to talk about it afterwards. So, um, and then if anything that's of course specifically Arduino related, then we would hope people would be encouraged to join the Build It with Arduino workshops that would happen 1 to 2 weeks after these meetings. So, so anyway, we'll get into that after the Around the Web coming up. So, and I think everything here, let's see, next week will be the Build It with Arduino, same Zoom link each month. YouTube video of this meeting will be on the web, hopefully within the next week. And then please be sure to share links and other things in the chat because that will also be included in the post. And okay, so let's start with we'll start with what you guys have to share. And I am going to stop sharing my screen so that you guys can share yours if you have something. So,
I have some,
who's
sorry.
got?
I got something to share.
Absolutely, go ahead.
Okay. So, good morning, unless you're somewhere where it's not morning. Uh, I've been standardizing the robot operating system. It's not an operating system, nor is it Ross, of my robots because I find myself, finishing one robot or getting as close as I could, and then, it's competition season for the next one, and I'm like, oh, what was this code like? So I'm trying to standardize all my code, and with that, I kind of separated everything out a bit. And so now I have 4 robots that essentially run on the same code, which is nice. Like from this little guy here, this is just like a backpack friendly robot that runs essentially the same code as the Robo Magellan robot. And I'm going to share my screen and kind of give you guys a rundown. Like,
Sure.
where's share desktop? Yes, this one. And then I gotta go grab something. So, don't mind the ChatGPT image, but this was looking for something quick. The idea is it sits all on a CAN bus. That doesn't look like Star Network, but you guys get the idea, and this thing isn't perfect. But the idea is it has multiple nodes, and node one is kind of like the mission controller, if you will. Now it has a Raspberry Pi, but the Raspberry Pi doesn't do much other than it has a CAN bus to MQTT bridge, which is a subject we talked about when I did my Node Red topic. So it does a little bit like dashboarding, and I can like start and e-stop my missions from it. But other than that, it doesn't really do much. The MSEN does like the arbitration, the avoidance collision, all that sort of stuff. And based on it knows what robot it is, so it knows its wheelbase and everything, and it has the drivers, common drivers it uses, but it talks to, well, it doesn't talk to these sensors. It actually looks for information from these sensors, and if it sees the heartbeat, it knows it can turn things on. So node one, node two is like my time of flight sensors and my IMU sensors. Um, and I put those on a separate node. The nodes look like, if you can see my face, like this. They're just Adafruit CAN RP2040 boards, right? So it's just a CAN bus connected controller. And I put those on their own node because those sensors are sometimes slow and they slow down the main loop, right? Even though you can have 2 loops on an RP2040. Node 3 is my second IMU and my GPS. And if node 3 shows up, it'll look for node 2 and grab its IMU data, and then it does sensor fusion with that. Node, there's 2 node 3s there. I don't know why. That's ChatGPT for you. Node 4 is the lighter. I'm going to demo that a little bit today. And then Node 5 is like all my user interface. Also, OLEDs are super slow, and I really, really wanted to keep the user interface on Node 1 because it made it as compact as possible when like going with the old backpack robot for, you know, playing around with this on the road, but it was not possible. So, and then Node 0 is the Raspberry Pi, like I mentioned. So I have I'm going to grab this screen. I guess I'll do this one first. Just to show you right now, my robot is running over here to my right, and I can't show it to you, but it's running and it's publishing information on my MQTT, right? Like odometry, poise. It hasn't moved. It's just sitting here. That's the voltage that's going into it right now. Time of flight sensors. There's only one that's active right now, so the other ones are showing that they're down. That doesn't matter too much. Oh, and it's cloud connected because it can connect to the MQTT. And there's another message here for when it can connect to my online black box, if you will. Uh, but I wanted to show you this one. This is running on the Raspberry Pi that's on the robot. There's two Raspberry Pis on either side of wireless. This one runs, and it's not needed for the mission, but it's kind of handy. And oops, this is you'll see the scan IDs are ticking up here, but this is the lidar, and the lidar when it connects, the lidar node, I should say, it's running. If you haven't seen a lidar or this one, this is what they look like. This one's a Slam Tech RP RP lidar C1, and I bought this one because it was like very very cheap over Christmas. And if you can see my video, I don't know, but it's just a cute little one. It's got some mounting holes on the back, but it's serial. So I take that serial at a really unfortunate and fast speed, something you wouldn't want to like try to service with a microcontroller that was trying to do a bunch of other stuff. And it just sits on one of these RP2040s and it'll spin the lidar up, and then right now, just as its heartbeat, it publishes, and you can tell it's publishing out at 1 hertz based on my screen. Um, and its heartbeat essentially with the CAN bus network is every 10 degrees. Yeah, 10 degrees. Every 10 degrees, it'll go and accumulate like the distances it can see 10 degrees all the way around it. And then as part of its heartbeat, if there's anything within 1 meter of the lidar, it publishes that as one. And if there isn't something, it's a zero. So you can tell because it's sitting on my bench, there's a whole lot of items closer than a meter to this robot. And that's just nice for like I mean, it's there, and maybe, kind of if it wasn't specifically looking for the lidar, could tell something was close and might do something about that. Not likely, but the lidar is there for actually both indoor and outdoor competitions, PopCan Challenge and Robo Magellan. But you can kind of see I can put my hands in front of it and like fill up some of this bit mapping a little bit more. Just things are getting closer. This is pretty worthless at 1 hertz, but this is its heartbeat, if you will. When I actually send a pi command to it, sorry, when I send a command over CAN to this device, I want to enable streaming, and then I'll stream this at 20 hertz, which is probably faster than I need. But it makes sure that I get the information I need. And at that point, I go to 5 hertz increments or sorry, geez, man, not enough coffees. I go at 5 degree increments, which is plenty enough for me to get a good solid map of what's around me. All of this feeds into essentially collision avoidance system. I don't do mapping with this. Um, I probably won't do any like big mapping. I'm not saying that's not valuable or interesting. That definitely is interesting stuff, but I don't really need it for the competitions because I'm navigating by a GPS coordinate, and essentially I'm just doing collision avoidance to get there. And then in the PopCan challenge, you know the map, so there's no reason to like go and world build. So it's really just, is there a tree branch or whatever? I mean, the interesting thing about lidars is, especially these ones, they can see a lot further than you necessarily want to see. And so my local area map, if you will, because they do have a local area map for um, just routing around things, um, is 2 meters. And I don't go any further than that because I found like my robots sit low enough that if there's a rise in the ground, it sees the ground like out 3 meters or whatever in front of it and thinks it's a wall or something. And all of a sudden, I'm trying to navigate around a wall when it might just be a gentle rise up. And so I really constrain the amount of space that I see around the LiDAR just because I don't want my, course planning to try to go around a gentle rise when I use my IMUs and if the rise is too aggressive, then it will consider that a blocker as it goes up a hill and try to back off and go around. But yeah, it's just kind of neat. I'm sorry, I was trying to get this done so I could stream the data faster just to show it to you, but I don't think really much matters. It's just kind of an interesting thing to show. The lidars are pretty neat. I mean, this is you see it's, five sets of bits, super consumable for a microcontroller, where typically you would be using this on a Raspberry Pi or some computational platform, which makes sense, but I don't need that, right? I'm running everything on microcontrollers on CAN, and that is super quick versus, trying to run it over like an operating system and all that latency. James, you got a question?
Oh, I always have questions.
Yeah.
Uh,
All right. I love them.
so, couple of things. I guess I don't. I didn't hear you say this, but I'm guessing that one of the really big advantages of this is that since you have like a Raspberry Pi, at least on a Pi Pico, I guess, on some of the modules,
Hmm.
the point is that you can do processing locally on that module and like only transmit the data back and forth that you really need. Is that correct?
100% with you. Yeah,
Okay.
I was really just showing off the LiDAR today, but where is Keynote? Hold on, let me
The
grab.
reason why I mentioned that is because there's a guy that I've been interacting with for a while on a Discord. I'm really happy that you guys are starting a Discord service, and you kind of don't know what you've let yourself in for by
Yeah.
giving me access to a Discord server. But there's a guy who has been doing a servo uh, node over CAN bus, and one of the things that is really cool about that is that he can like put the physics like interpolation between two, so he can like just give it a goal position, but it won't
Mhm.
just try to go instantly to that goal position, to like interpolate or accelerate to that goal position or speed. And, other things like he's talked about like adding encoders or feedback or like load, stuff into it. He likes to work with ESPs, but I guess you're working with Picos. And then the other question that I'll throw out there was I was just curious what you're using for the user interface. Did you?
Oh yeah, yeah, absolutely. So yeah, you're right. I mean, the reason for CAN is that I don't have to overwhelm the processor with a bunch of things that I might not care about at the time. So I can subscribe. It's not really subscribing, but I can filter out everything I don't want because everything goes across the CAN if you put it on the CAN. Um, and if I care about something right now or later or whatever, I just, I open up my filters and I ingest that CAN data. If I don't care about it, I just filter it out of the CAN bus and I don't even have to like pull it. I have to like, I don't even have to pull service it, I guess. It's not, I don't even have to say, is this a CAN message I need? Yes or no. Like the hardware will do filtering. Just to your point, yeah, like everything from local goal layer down, it sits on the so this is just the architecture. Local goal layer. So the microcontroller takes care of like all local goals. I need to go here. And really you can run I can run entire like build challenges out of the local goal layer. I don't need anything else. But this is all abstractions that I'm working on right now. This isn't done, and this is just a power presentation for later. But I can probably bring that up real quick. Where is this at? The dashboarding, the whole purpose of this, the entire purpose of this is for dashboarding and control because as you know, when you're sitting there live working on your, oh, sorry, I meant to put UI. Well, this is
What you're about to say is that you spend half your time going, "What the heck are you doing?
yes,
Why are
exactly,
you
James.
doing that?"
What in the world is it doing right now?
And having
So,
having instrumentation really makes a massive difference there.
absolutely. So instrumentation and logging, right? So
Well,
I
wait,
want to
okay,
see.
so you're talking about a web dashboard here, and I was seeing a physical UI. That's what I was
I have
asking.
both. Yeah, I have
Okay.
one that will, I don't need this, but from the robot itself, this one doesn't have it in my lap, but from the robot itself, it has like a little OLED with a rotary encoder. So I can initiate the competitions from the robot without any web UI. But I also have this for my tablet. So if I'm going along and I want to e-stop it from here, I can click the little e-stop button and release our bar. This is work in progress, big time. And then I can go in and adjust my mission parameters over here. But I can sit there and watch like what's my IMU heading and what's my target. Man, oh man. And many of us can attest that like sometimes your robot starts going off somewhere and you're like, why are you going that way? And I want to know, is that its target or not? Does it believe it should be going that way or is there a problem? And then so yeah, so I have both UIs. Yeah.
I love that you have the main power bus as a large thing over there on the side, because I just have to say that only a complete idiot would spend like an hour trying to figure out why the code that was just working perfectly suddenly isn't working without realizing that you should check to see
Uh,
whether or not there's a problem with the power system
so
that's
you
causing it to brown out. I mean, only somebody really dumb would spend an
only somebody, a
hour company
complete
time
idiot,
doing
would
that.
say, like, why isn't it going? And you realize your power supplies have like cut out on low voltage. And yeah, I hear you. So you feel the same feels I got here.
Yeah. So just
Yeah.
out of curiosity, on the LCD UI, what code are you? Did you just hard code something in order
Yeah.
to? Okay.
Yeah.
If you want to, I have a project that I've been trying. It's a solution looking for a problem to solve related to building LCD UIs that are inexpensive and get the job done without a bunch of complexity. So if you're
Hmm?
interested, I'll share a link with you.
Absolutely. Yeah, absolutely.
Awesome work on this, by the way. This is the future. This is the way to go.
Yeah. So yeah, thanks. I'll share more with it later. I'm working on that upper level stuff right now, and it's been a lot of fun, and it's really nice because you guys know if you're working on more than one robot or you want to reuse it, it's really nice to be able to reuse everything. So like going in with design intent that this is going to be used on more than just one robot platform has really helped me out. In making sure that like, okay, I have my build challenges 1 and 2 robot, but I also want to be working on my PopCan challenge robot, but I also want to be working on my Robo Magellan robot. And now I'm working on all four when I'm working on one, which is really nice. So,
Right.
yeah. Thanks, guys.
Okay, looks like Craig's got something that he'd like to show us there.
This is an old version of an autonomous slot car, and I'm building another one for a competition at Clover Park Tech coming up here in a few weeks. The version on the screen has it's a Raspberry Pi, and the next version will be just Chow, Ceeduino Chow ESP32 S3 Sense without the camera. I'm using the S3 Sense because it has the built-in SD card that I can use for logging. So having fun with that. I put the Scotch broom puller and the mower aside for while I'm playing with this now.
Looks like fun. All right. Yeah, keep us posted on what you're doing with that thing.
Yeah, will do.
All right. Thank you.
Hey, just a little bit of a political announcement. For those who don't know, the state legislature, there's currently a bill, House Bill 2321, which seeks to ban the sale of 3D printers in the state of Washington unless they have software that will absolutely reject printing of any 3D guns or gun parts. And if you can imagine, when you say gun parts, that's a cylinder, right? That's buttons, things that you can use as triggers. So this is something that's absolutely ridiculous. And I would urge all of you that are interested in 3D printers to tell your congressman they're being idiots.
Wait, just so you know, your state is not alone in this. California has also
Right.
introduced a similar bill, which is equally moronic. I hear next they're going to pass a bill that says that all lathes have to have a webcam trained on them at all times with AI recognition software that can detect if somebody's trying to make a cylinder that might be turned into a gun barrel.
I believe it. I mean, it's just absolutely absurd. I guess we're getting back to stone axes and knives.
Yeah. Yeah.
You can't 3D print those either.
Probably
Yeah.
not.
That might be used as a weapon.
Uh,
Just a really quick comment. As a decorated veteran of a foreign war, I am not a big fan of weapons and guns because I've seen what they do to people. But that's not what this is about. I just want to be clear. It has nothing to do with whether you're pro or anti-gun. It's about the fact that the law is completely stupid, completely unenforceable, and will cause massive damage to a wonderful industry. That's the issue.
right.
I agree. That's absolutely right.
Yeah. Okay. Thank you. And yes, it's. I was just reading about that, and I was just shaking my head, going, "Oh my goodness!" Talk about Okay. Let's see here. Let me turn my camera back on. All right. So let's see. Oh yes. Actually, you've got the.
I had the thing queued up and then I cleared it.
Oh, okay.
I can pull it up again if.
Actually, I think. Let me get this. If we're given our time here, I want to go ahead and launch this this tech ed video that I have planned here. I don't see any. Is anybody else? If you do have something to share, I think what we'll probably maybe try to do is we'll do the round the room, maybe a couple of people that have things, and then we'll go into go into this, and if you have something, just bring it back next month.
Okay. I can run it from here if you want.
Okay. Why don't you? Okay, Lloyd, why don't you go ahead and do that?
Okay, hang on just a sec while I get this guy up.
If you need 3D printing services, you need to try Xometry. Xometry offers a massive. If you remember.
Okay.
Okay. Let me get this
So
over here.
just a quick intro here. So this is the guy that did the video here went and probably went on Amazon or someplace and just bought one of these multi-sensor packs. So you can go out there. You could they start what? $15-20 at the bottom end, and you can $50-60-70 at the high end, and you can get so many different kinds of sensors, and it just gives you opportunity to just play around with these things. And they're cheap. They're sometimes they come with decent documentation, sometimes not. So anyway, this guy's just going to go through these different sensors and just kind of introduce them and show what they do. Not going to be anything earth-shaking for most of you guys, but hopefully it'll be something interesting to you anyway. Go ahead, Lloyd.
Remember, a few weeks ago I've made a video about types of displays that you could use in your project. Well, I would like to do the same but with sensors that you could use with Arduino or other microcontrollers. Obviously there are a lot of sensors and I can't get them all, but I would like to show you the sensors that I have around my workshop, show you an example code for each, and talk about the use of each of these sensors. We have a lot of sensors, and some of these have a digital output or an analog output, or some sort of I2C or SPA communication. This will be another basic video, but in this way you could make an idea of what projects you could start with an Arduino and some sensors. I hope this will help beginners, or for those who are not beginners, well, see some more sensors that we have on the market. Before we start, make sure you hit the subscribe button and the notification bell in order to see my future videos. Also, thanks to all my patrons for the support. So let's get started. This video is sponsored by JLC PCB that offers the most economic prices for PCB services right now with only $2 for 10 PCBs of 10 by 10 centimeters. The finish of their PCB is very professional and high quality. So just upload the Gerber files to jlcpcb.com, select the thickness, the size, the quantity and so on, and place your order for amazing prices. What's up my friends, welcome back. So I have a bunch of sensors here on my table. A breadboard, my oscilloscope and an Arduino for tests. I won't go with each Arduino code step by step, but I'm sharing below the schematic for each example and the code with comments for each line. So make sure you read that before uploading the code. So, what could be a sensor? I mean, even a push button could sense something. It could detect if I push the button or not. That's pretty obvious. But we don't usually refer to a push button as a sensor, more as a detector. So a detector is the result after the sensor process to say if something is or is not. For example, this entire module is a so-called movement detector. If it detects movement, it gives a high output. If we don't have movement, the output is low. So we couldn't call this a sensor. But inside this module we have a PIR sensor, or a passive infrared radiation sensor. This will sense the amount of infrared radiation and give that amount to an integrated chip, this one here. And that will calculate the difference and say if there was movement or not. So the detection process needs a sensor, a device or a module that could sense the events or changes from the environment and then send that information. So let's just make the difference between the sensor and a detector. The sensor is the device itself that gives information or data according to the surroundings or situation. And the detector will be a device, so let's say an Arduino for example, that will give the detection output. I've tried to separate my sensor in 3 packs. Here I have those who are light-related sensors. Then I have the magnetic, the pressure, the gyro and acceleration sensors. And this final group, well, is just general sensor with all kind of purposes. Let's start with this pack here. First we have a color sensor that is based on the TCS 3200 chip with photodiode filters for red, green and blue colors. This module will apply white light and sense the response frequency of each color that is reflected. Of course, a red object will absorb all the colors but the red one, and so on. So you should run this example that will print the response for each color and place a red, green and blue color in front of the sensor and note down the ranges of each color so you could then detect the colors. For example, here I place the blue side of this Rubik cube and I can see that the blue response is getting lower. Note down the values for each color. You have the schematic, an example code and a full tutorial about this below. Okay guys, next we have this heart pulse sensor. It combines a simple optical heart rate sensor with an amplification and noise cancellation circuit, making this fast and easy to get reliable pulse readings. You will also need to install processing for this example. Make the connections and upload the Arduino code to the Arduino. Then run the processing and get the serial data from the Arduino and we could print the heart pulses to the screen. This is pretty nice, right? Okay guys, next we have the PIR sensor, or a passive infrared radiation sensor. It detects radiation changes, and since our bodies radiate heat in the form of infrared radiation, we can detect movement by detecting these changes in the infrared radiation. So make the connections to the Arduino and run the example code. The sensor will give the high output each time it detects movement. In this example, I turn on this LED each time that I detect movement, as you can see here. I move my hand and I turn on the LED. This sensor could be used in so many applications, where you could turn on lights, set an alarm activated by movement and so on. Okay, the next light-based sensor is this infrared distance sensor. As you can see, infrared light is used very often. That is because we are usually already surrounded by visible light, and that will result in a lot of noise. Okay, this module will send an infrared beam. Then it detects the bounced beam of light, and depending on where the light touches the sensor, it can detect the bounced angle and by that the distance to the object. These sensors can be quite accurate.
Progressive makes it easy to get a quick commercial auto quote online, so you can get back to all your other.
I have one that goes from 15 centimeters up to 1 meter, and another one that goes from 1 centimeter to 10 centimeters. It will give an analog output according to the distance. Here I have it connected to my oscilloscope, and as you can see, by moving an object in front of this sensor, the output value will change. I've used this kind of sensor in my 3D scanner project, since it has some decent precision when measuring small distances. Connect it to an Arduino and upload the example code, and you could print the distance to the serial monitor or to the LCD screen. You will need the distance to voltage graph in order to know how to map the distance in the Arduino code. Read the code for more. Okay, I also have this laser-based distance sensor with the VL53L0 chip. This is one of the smallest packages on the market for a laser-based distance sensor. As you can see, it is very small, so you could place this one on any kind of PCBs and detect the distances or gestures. It uses an I2C communication to send the data, and it could measure up to 2 meters in perfect conditions. It measures the distance by detecting the reflected laser beam. Connect it to the Arduino, install the needed library that you could also find below, and run the code that will print the distance in millimeters to the serial monitor or to the LCD screen if you have one. This module has a very good precision for distance, so have this chip in mind when preparing your projects. It is also quite cheap, just a few dollars. Another light-based sensor is this direct infrared sensor. This module has an infrared LED that will send an infrared light. Then we have the phototransistor that will detect the light it reflects on an object in front of it. This kind of sensor could also be used as a switch, as these small modules do, where the emitter and the receiver are one in front of each other, and could detect when something is in between them. I've used this sensor in a lot of projects, such as the encoded DC motor to count the steps, or the infrared remote to send and receive data using infrared light. As you can see on my oscilloscope, more infrared light we get, the higher will be the output. Or if we have the module into digital mode, it will switch to high when we are close enough to the sensor. This module has an amplifier, and by setting the threshold with this potentiometer, we could detect stuff. For example, fire emits a lot of infrared light, so we could sense fire if we want. Download the example code and upload it to the Arduino, and you could print the analog output to the serial monitor or to the LCD screen, and then you could activate stuff, for example turn on an LED when we detect fire. Finally, the last light-based sensor is this LDR, or light-dependent resistor. This resistor will change its value according to the amount of light that it receives. So if I create a voltage divider and apply 5 volts to it, we could measure the voltage drop and see how it changes according to the light. We can connect this to an Arduino and detect the visible light, and maybe create a light following robot or any other idea that you have. You have the schematic and a simple example code below, together with the full tutorial on my webpage electronoobs.com. Okay guys, now we have this other group. Here I have an IMU module and a magnetometer. We've seen this IMU module in a lot of past tutorials. This is the MPU 6050, and I also have the MPU 9265 module. It can sense gyro forces and accelerations. With these values we could calculate the angle as well. Below this video you have a few examples. This module uses an I2C communication to send the data to the microcontroller. So connect it to the Arduino, and you could for example print the orientation angle to the serial monitor or to the LCD screen. You could also print the raw values of accelerations or gyro data. You could use this sensor with drones that must fly horizontal. Also, you could detect accidents by sensing the accelerations, and when the peak is detected, well, that must be a fast change of acceleration, so it might be an accident. You could also detect if something moved. If you detect gyro or acceleration changes, that means that the object on which the module is placed moved. This is a very interesting module. Okay guys, I also have this magnetometer. This module is the HMC5883, and it uses an I2C communication to send the data. This measures the Earth's magnetic field, so we could create a compass and detect where is north, and by that orient us in space. This could also be used with drones, together with a GPS module, so we could know the location of the drone. You could also use this to make measurements of the Earth's magnetic field. Connect the I2C pins as in the schematic below and upload the example code that will print the magnetic values, and that's it. Okay guys, now I have this atmospheric pressure sensor. It will measure the pressure, so with that we could get the altitude. The higher in the air we are, the lower will be the pressure, since we have less air above us pushing us downwards. The module has an I2C communication as well, so connect that to the Arduino and then install the needed libraries that you could also find below. Run the code that will print the pressure and the approximated altitude. You could use this module for a weather station project or for a drone, so you could implement the altitude hold configuration for that drone. Check more details in the link below.
I have a 134 IQ. I make less money than friends who barely passed high school. Here's what I...
Okay guys, we finally have the last group of sensors, which are quite general. Let's start with this gas sensor. Now, depending on the type of sensor, you could detect specific types of gases, as for example inflammable gases, air quality or alcohol detection in the air that you exhale. But in this case, this sensor will detect the changes in the normal air percentage of gases. It uses an amplifier. It could have an analog signal as well, or directly the detection signal, which could be high or low, meaning that the normal values of air are not right or that the air is clean. Connect this module to the Arduino and upload the code. It will print the analog read from the sensor, and by setting the threshold values, you could detect the air quality changes, or any other gas by using a specific gas sensor. As you can see, when I release gas from this lighter, the analog output increases, and that means that we have a gas leak. Okay, the next example is the common distance sensor using ultrasound pulses. It sends a sound wave, detects the bounced wave, and it calculates the time it took the sound to get back, and by knowing the speed of sound, we can get the distance to the object in front of the sensor. I've made a full tutorial on how to make a sensor like this one, so check that video for more details. Connect the module and upload the code, and it will print the distance in centimeter onto the serial monitor or to the LCD screen if you have one. Read more about this on my webpage, and read the lines in the example code for more. Okay, now I have a thermocouple voltage sensor. The thermocouple is a component that will create a small voltage drop on its connectors when it's heated up. By knowing the temperature versus the voltage drop relation, we can measure temperatures. Since the voltage drop is very small, we need this kind of sensor that uses the MAX 6675 amplifier. So connect a K-type thermocouple to this module and make the connections to the Arduino. Then upload the code and run it, and it will print the temperature. As you can see, I heat up the thermocouple and I get the real value of the temperature. This kind of component is very useful when working with high temperatures, since it would withstand up to 700 degrees. Okay, now in the same way I have this thermistor, which is a temperature dependent resistor. As in the example with the light dependent resistor, we could create a voltage divider, and we will see that the output voltage will vary depending on the temperature. If we know the thermistor response, we can measure the temperature with the Arduino. As you can see, when I heat up the thermistor, the resistance will change, and as you can see on the oscilloscope, the voltage divider output will change as well. More information below. Okay, I also have this current sensor. This module uses the MAX 471 current sensor. Connect this module in parallel with the load, and it will measure the current that the load uses. I make the connections and I add a resistor as a load, and I use this power controller to vary the applied voltage from the battery. After I upload an example code, it will print the current values, and as you can see, I increase the voltage and the current increases as well, and that gets printed onto the screen. This is another very useful sensor for your projects. Now here we have a Hall sensor. This small component could detect magnetic fields. I've used this kind of sensor for my POV clock project and for the sensored electronic speed controller. This is the 49E Hall sensor, and this one has a linear output. If I make the connections to 5 volts and ground, as you can see, when I place a magnet close to this module, the output will increase or decrease. I could connect this analog output to an Arduino and by that detect magnetic fields. You could use this as a switch or an encoder on a motor shaft or any other idea that you have. Once you know how to measure the output, you could use this for any project. It is very easy to use. You also have the digital type where the output is high or low, and that means that the magnet is close to the component or not. Okay, so finally I have an ADC. Now you could say that this is not a sensor, but technically it sends the analog value. You could use the ADC of the Arduino, but that is only a 10-bit converter. For more precision, I have this 16-bit ADC. This will give me 65,000 points for a range from 0 to 5 volts. That is a resolution of only 75 microvolts. It uses a nice crazy communication as well, and it has 4 different analog inputs. This is a great module if you want precision. I make the connections, and now, as you can see, it prints the analog value from this potentiometer to the screen or to the serial monitor with very high precision. So have this module in mind when you want good precision for your analog reads. So that's it, my friends. These are more or less the sensors that I have right now laying around my workshop. There are much more on the market. So I hope that this video helped you to make an idea of the amount of sensors and how to use each one of them. Consider supporting my projects on Patreon. If you like this video, make sure you subscribe and activate the notification bell for future videos.
Okay, all yours.
All right, everybody hear me again? Oh,
Yep.
okay.
So
Okay.
he mentioned
That was very basic, obviously. Most of you are way beyond the stuff he's talking about. But and I will make one comment toward the end there when he was talking about the current sensor.
Yeah.
So put it in parallel. It's like no, you got to put that in series with your load, not in parallel with your load. You know, you don't put that thing straight across your power supply or you're going to fry it. So, but anyway, you know, obviously there's a lot of things out there. Lloyd, why don't you bring up that Amazon page
Oh,
with
the Amazon page? Okay.
yeah,
Hang on. Let me grab that.
yeah. There's I have a bunch of these myself, you know, and it's incredible how cheap these things are when you buy them in bulk like that. You know, you could get, and if you're just looking to play around with a bunch of these things, it's amazing how many different things there are out there. And I do like that these modules they're all, you know, they've got amplifiers and, you know, the signal conditioning for the sensor is already built into most of these modules. So they're ready to interface to a microcontroller without having to build a circuit. You know, you might say toward the end there, he had a little, let's see, was that a Hall effect that he
yeah, he had a Hall effect.
yeah, a little Hall effect sensor, and he'd actually built his own little circuit board. And it's like, well, you know, you could do that, but you probably don't have to. But you know, you look at some of these kits. I mean, what's that one there? 37 sensors for $20. It's like, good grief.
Yeah, there's 38 for 16.
30, yeah.
37 for 20. There's 37, well, for 20.
Yeah. But so anyway, there's a lot of interesting possibilities.
There's 48 for $50, about $1 a sensor.
Jeez. Anybody has anybody played around with some of these multi-packs like that?
Yeah, when I was buying stuff for Donna's class, I got a thing like that with a oh, what's it called? The Mega included one of these packs in it, so it's got quite a lot of stuff.
Cool.
We got one from the local supplier, not off Amazon, but the same sort of a, you know, like multi-module kit. When we were doing when I was teaching the robotics class for UCSD extension that was Sally Ride Science. Oh. And it was pretty good. One of the problems with all of these is you want to make sure that you have like code support, you know, and good documentation, because you know there's code already for all of these sensors, right? But like if you buy one of these kits, you know, sometimes the pin numbers aren't labeled very clearly, or that particular sensor works in a slightly different way, or, you know, blah blah blah. So just, you know, check to make sure that they have a link to, and no, I don't think any of these do, but if you find one that has a link to a repository of GitHub code that specifically works with those modules and, you know, has documentation, or just look at the pictures and verify that the soap screens like clearly label the pins and actually show what chip it is that is on that module. That's the only thing I would advise.
I was, this guy's video there, he made numerous references to below his video. So, and I will include the direct link to his YouTube video too. And what I liked about his little instruction there is that he does provide links to the code for those different modules that he was demoing. So, yeah, I discovered, I think it probably, particularly if you're running into something that does serial communication, you need to know the details of the protocol to be able to interpret what the thing is doing. So, okay, so we are ready for a short break here, and I'm going to let Lloyd go ahead and get.
I can put a timer up.
Yeah, he's going to put a
I can
timer on the
remember where I
screen
put
here.
timer.
And let's see, what do we got? It's like about 11. I got about 11:06. Let's see, what do we need?
5. You want to do 5 minutes?
Okay, does that sound good to everybody? We'll do a 5-minute break.
That's a terrible timer. Where's the timer?
And then
It's
Lloyd.
got pretty colors on it. How can it be a bad timer?
Well, this is the one I used before, and they've apparently upgraded it. So
Yeah.
we'll go with that.
Okay.
Live clock, your device time. Okay.
So go ahead and however you start that thing.
Yeah, there's the start button.
Ah.
Okay, 5 minutes. Okay. We're going to take a little break. You want a power bar or anything, Steve?
Oh, sure.
Okay, let me hit this side real quick.
A little let's see, what did you say your cat's name is?
Okay, no more coffee, more water.
Maybe I'll have a up here and
You don't want to give me caffeine. I'm about to talk. It would go very quickly.
okay. Okay. Well, you can make up for the all the time, right? So when I started walking down the hall, your cat and went around, tripped on the cords behind that little table there.
I just saw he shot back into the bedroom too. So
Yeah. So he's thing is, I'm watching this video where he did one on displays. That might be a good. So that would be a good one. Because I haven't built a robot having it built to display, but I always thought that's really handy just to have some basic data on the robot.
I use that with Microsoft. They have super simple library talk to it.
Okay.
But wonderful.
Yeah. It seems like the kind of the thing
They call it a library.
so it's yeah, so I'm kind of intrigued by that. So
Yeah, it is.
yeah, so I'll look into that.
We'll go back and forth.
Close. There we go. All right.
Yep, 30 some seconds.
Okay. Good.
Okay.
When everybody is back. All right. Well, this is a man who doesn't need any introduction. So,
But I do need to get my screen set up. So. Why? There it goes.
I'm still seeing.
Okay, I'm not sharing yet. So.
Not sharing yet. There we go. Yeah.
Okay.
All right. There we go.
Does all that look good?
Yes, it does. Spooky, ghostly Steve. Yeah. It's a
What is this doing here? This doesn't need to be here.
All right. Well, take it away, Lloyd.
Okay, just a second. We had a small snack and I'm still working on it. Okay. Okay, so this is going to be a talk on choosing the right programming language for your project. Obviously, well, part of the point of the talk is one language is not, good for every project. So when you're starting a new software project, the language you choose can really lead to the success or failure of the project. Frequently, this gets little or no attention. Everybody just tends to choose the default language, the one they know, the one their company uses, the one their group uses, the one their friend used, whichever. And that's just kind of what happens. Point of this talk is to get you to think a little more proactively about that. We're not going to look at any specific programming language. What we are going to do is walk through a list of properties that programming languages have. The goal of this talk is to get you to think about a programming language as a set of features and properties, and then match those features and properties to what your project needs. So this will give you a framework for looking at a set of languages and saying, this is going to be the right language for this project. Or in some cases, this part of the project. This talk actually came from a comparative language class I took in college. Frankly, I'd love to see if anybody's still doing this. I have not seen a comparative language project or a comparative language class in any college curriculum in decades. Now, I don't look at a lot of them, but it seems to have gone away. And I found it very, very helpful in my career, being able to look at different programming languages and say, hey, this is what this language brings to this project. So the various language properties we're going to look at, and we'll go through all of these, but just an overview. General versus domain specific, that's a first cut. The language class or genus, the way it's translated, the way memory and threads are handled, and those are all kind of language properties. Then there's other.
Just one quick, if anybody's got any questions, shoot them into the chat, and then I'll watch the chat and let Lloyd know if you got questions.
Okay, good, thanks. Yeah. Anyway, the first they're kind of properties of the language. We're also going to look at properties that are around the language, not part of the language itself, but that will apply to which your choice needs to be. Basically, industry standards, company familiarity, community support. We'll talk a little bit about regulated environments. Folks know I've been in some of those, and those are kind of a special niche area. Portability, automated tooling. We'll touch on AI slightly. That's kind of a new one. Execution environments and production status. So the first of these is basically a general versus domain-specific language. So a lot of us are very familiar with general purpose languages. C, C++, Rust, Python, Java. These are all very general purpose languages. There's also domain-specific languages, and you use them, you may not recognize exactly what they are. SQL for database access. HTML or CSS for web pages. If you've done circuit design, there's VHDL and Verilog. Build systems, CMake. Actually, Make would be another example. QML is built into the Qt development system. And for many of these cases, the default is just the right way to go. For instance, if you're going to query a database, right, in a high level, SQL's just the standard, right? Just do that, right? It's you're not going to find or develop anything better for a small project. If you're working with web pages, HTML, right? That's just kind of what you need to use. A question to ask is, if you're starting a new project, is there value in creating a new domain-specific language? Most of the time not. Sometimes there is. You may want to build up your own language to simplify coding, and you can think of a domain-specific language like a collection of macros, right? It's kind of a step further than a library. It's a worthwhile question to ask. Usually the answer is no, but not always. Next one is the language class or genus. This is essentially getting down to how the language works, right? There's different classes of languages. Just like with human languages have families, programming languages have classes. In particular, what's known at compile time and what's left at runtime. That's kind of a first cut. So do you have an interpreted language or a compiled language? Then you could break it down a little further. There's procedural languages. So Fortran and C, these are simple. They've been around for ages. They're just straight procedural languages. Building on top of those, you get the object-oriented languages, C++ and C#, among others. These map well to modeling complex objects. So if you're going to be modeling complex objects, you may want to go object-oriented. Declarative languages like SQL and QML specify what to do, but not how to do it. These tend to be a little more special purpose languages or domain specific, but they're kind of a family to themselves. Functional languages such as Haskell and Lisp, these have definite advantages for reliability. Functional paradigm restricts what you can do in certain ways that you can make additional guarantees about the code, right? And scientific apps tend to use those, somewhat commonly. And then there's others such as logic languages, reactive languages, aspect-oriented languages, data flow languages, stack languages, constraint. There's, there's tons and tons of these. The basic idea is if your program or your problem fits into one of these languages, it naturally use that language, right? If you're just doing something simple, right, like blinking an LED, you probably don't want to do it in SQL, right? You think I'm joking? I've seen people do things about that bad. Use something simple like C. If it's more complex, use C++ or C# or Rust or something like that. If you know what you need to do, but not exactly how you want to do it, SQL's the great example of that, then you're going to be in kind of a declarative space. Okay, a lot of the languages come in two flavors. They could be compiled or interpreted. Even something like Python, what is it, CPy? You can compile Python, right? So even once you've chosen the language, you then, depending on the language, you then get the choice of how do you want it translated. And essentially that gets you different advantages, right? So what must you express during development versus runtime, right? That's the kind of a first cut. What do you know at compile time versus what's left to runtime? What's your runtime performance? How critical is that? Computers are fast enough these days that even something like Python, which it's not that performant, but you're not going to notice, right, for most apps. Do you have real-time limitations? If you do, you probably want something compiled. What's your startup performance? Again, usually you don't care, but there's some environments like, say, robotics. And when you have a failover processor architecture where you've got two processors and you're going to reset one of them and bounce back and forth for reliability, startup is a big deal, right? You need to start up in fractions of a second in some cases. And then your executable and execution environment size. Basically what you're doing with compiled versus interpreted language, you're trading work done during development for work done at runtime, okay? The work's all got to get done. It's where do you do it? You're trading knowledge specified during development with flexibility at runtime. You're trading determinism during development with flexibility at runtime. And you're shifting the environmental complexity between development and runtime. So basically, if you're using a compiled language, everything's kind of built, and your runtime environment can be quite simple. For example, on a small microcontroller. If you're doing an interpreted language, you're going to have to either bring the you're going to have to bring the interpreter along with you into your runtime environment. And although I've seen it done, it doesn't fit really well on a small microcontroller. JIT kind of gives you the best of both worlds.
Define determinism when you get to it.
Okay. JIT gives you the best of both worlds and the worst of both worlds, right? So you're getting compiled, and JIT is just-in-time compilation. You're getting compile times or compiling during your runtime. The question came up of defining determinism. So this actually kind of sits best in a context. Basically, if something is deterministic, it's going to behave the same way every time you do it. If you're looking at something like probably the simplest thing I can think of, and we'll talk about this a little bit later, about bring it up now, is garbage collection. Okay, so some languages, you manage all of your memory yourself. Some languages, the environment manages the memory for you. So C and C++ Well, let's just stick to C. C++ has got a couple other dimensions in it now. The C programming language, you generally manage all your memory yourself, right? You malloc it and you free it. You have control over exactly when that memory comes in or it's allocated. You have exact control over when it's freed. If you're using something like Python or Java, it's garbage collected. You do not necessarily know when that garbage collection is going to run. The environment makes that determination for you. So with respect to memory allocation in C, it's completely deterministic. You define it in the code, you tell it when to free the memory, right? And you know when that process is going to occur. In Python, it happens for you when the Python environment feels like it, right? And it will not, and I guarantee it will not happen at the same point in your code every single time. So that's non-deterministic, where C is deterministic. Does that get it?
Yep. Got a comment from
Okay.
James here.
Okay.
So James says compiled code is checked during compile, so it's most likely to work every time, no matter what data is sent to it. Interpreted code only checks the syntax, but the actual operation depends on the data, which can cause the program to follow different paths. So it's more likely to expose bugs when run versus when compiled.
Yep. And
I suddenly sound so much better. My voice is lovely.
Actually, I'm going to go one more step with that because this is actually a scenario I ran into in Python. Python actually, and several other languages allow you to do this as well. Python just happens to be really notorious for this. Python allows you to redefine aspects of your runtime environment dynamically. And with Python, depending on what you load into your execution environment, you can actually remap very large portions of the language if you feel like it. Bottom line, don't do that. We did it by accident, and it was a bit of a nightmare because we weren't expecting it. Okay, but for instance, getting back to the translation method, if you're interpreted, those kinds of things can happen, and they can be a benefit because, for instance, in the case of debugging, you can mock particular library calls or features for debugging, and then take it out during runtime. In compiled languages, that's not going to happen. It's all once you compiled, you're set. Okay. Other questions before I jump next topic?
Looks like we're
No questions. I just can't shut up.
That's okay. Okay, memory safety and management. So I hinted at this one a little bit earlier. Programming languages are built upon an execution model or a machine model. The key aspects of how the memory is represented and managed are built into these models. Most everything we use today is a simple, flat memory model, right? That's not completely true, but we're just going to stick to a flat memory model for this topic. I do want to note there's other types of memory: transactional, banked, paged, dual-ported, multi-ported. You can get all kinds of crazy architectures to do particular things in hardware. But we'll talk about just flat memory models for the moment. The next question gets down to how does the language manage memory? And manual memory management is the basic, right? That's how it's been traditionally done. It's the most flexible. It's required in some areas. If you're doing low-level hardware access, you're going to be required to directly manage, allocating and buffers and handing them off to the hardware and so forth. It's also the most error-prone and least safe, right? This is how C basically does it. Again, it's the most performant because you're doing it directly, and it's the most deterministic because you're doing it directly, right? You know how it's going to be done, and you know when it's going to be done. The next step up is reference counted. This is very flexible. It can be used basically anywhere manual memory management can. And it provides very good safety if it's actually used. It's good performance, and it's good determinism. Most languages, even though they're reference counted, are deterministic, although as the developer, you may not exactly know when the memory is going to get released. So in reference counting, what you're doing is you're saying, here's a piece of memory, and every time I create a new reference to that, I bump a counter, right? So the memory gets automatically created for you when the first excuse me, the first time you reference it. Every subsequent time, you bump a counter. When that counter goes to 0, the memory is released. From the code, you don't necessarily know when that counter is going to go to 0, but you do know when it's going to get released. Okay, so it's still generally deterministic. Garbage collected, we talked about this one a little bit already. It's the worst flexibility because everything is managed for you. Oh, one more comment I wanted to make on reference counted. Sorry, jumping back for a second. Reference counting is a very good balance if you actually use it. So some programming languages, C++ in particular, you can do any of these, right? Depending on the library you put in there. I can do manual, I can do reference counted, I can do garbage collected, although garbage collected isn't super common. The key there is, though, you've got to use it, right? And the libraries have to use it. So sometimes you can mix and match these. Okay, garbage collected. It's the worst flexibility. Everything is managed for you. It's the best safety. Everything is managed for you. You're not going to get a use after free with a garbage collected environment because it's managed for you, right? If you're going to use it, it's the environment and the language make sure it's allocated. I do want to make one comment here. A lot of people think garbage collection means, or garbage collected languages cannot have memory leaks. That is absolutely not true. You still can leak memory. And matter of fact, you can still leak memory in reference counting as well. If you make strong circular references to memory, so memory block A points to memory block B points to memory block A. Guess what you've just done? You've created a circular loop.
Okay, another question for you when you're ready.
Okay, and that will not be released. Your reference counters won't go down. Well, you can if they get deallocated. But like in a garbage collected language, that will just sit there. Garbage collection is also the worst performance and worst determinism because everything is managed for you. Okay, question.
Okay. Doug Bell is asking here, how do you know when it will be released? Is that a status returned by the call that you made to reduce the reference count?
Yeah, so the question is basically, how do you know when a piece of memory is going to be released? So I'm gonna break that into all three cases. I think you were just talking about reference counting, but I'm going to actually use that as a good example for all three. In manual memory management, you know when it's going to be released because you call free or delete. I'm using C and C++ language here. But you make a specific call that deletes or releases the memory. So in manual memory management, you know exactly when it's going to be released. In the case of reference counted, you make an implicit call, and that causes the memory to be released. So when the reference count goes to 0, right, and you know that because you released a reference to the memory, be it a pointer or a handle or whatever you're using, it will be released typically synchronous with that call. So the count goes to 0, somewhere in the environment, there's a statement that says, if count goes to 0, call free, right? So in reference count, you don't know exactly when that count is going to go to 0, but you know you're going to or at least have the potential to release memory at any release of a pointer or handle or memory reference. In garbage collected, you have no idea. Essentially what happens, the reference to the memory gets destroyed, and then at some time later in a garbage collected world, the garbage collector runs, which is another process which essentially stops all execution of your program. It goes through all memory that's being held by the program or has been held by the program, and basically walks that whole list and says, is this currently being used? Okay, it is. We'll leave it alone. Is this currently being used? No, it's been released. We'll clean it up. And this is a fairly intensive process. So if you're working real time, don't do garbage collection. It will mess you up. Does that answer the question? Hopefully?
Yeah.
Okay.
Got another one.
Oh, got another one.
Okay. Are there memory monitoring utilities that help you see the locations used or freed up graphically?
Yes. So depending on the environment you're in, there's different ways this is done. In the C++ land, essentially what you can do is you, at link time, hook the malloc and free calls, and you do this by replacing the library, essentially. In C++, you could also do new and delete. You essentially hook the memory allocator and replace it with something that essentially tracks and logs that memory. And then you send that out to a debug console. I'm not sure, I haven't seen any that do it graphically. It's usually in more of a table format. You can also do it with Valgrind in the Linux world. That will check your memory. Basically when your program runs, it hooks all the memory allocations under the covers. It keeps a list of what's been allocated and freed, and it will then, do statistics on that. Garbage collected, I haven't done much with those, but I believe you can hook those into debugging sense as well. So yeah, there are tools. They all work by one mechanism or another, hooking into the memory allocator and keeping a log of what's been allocated and freed. And actually, I can see James has a hand raised. That just popped up. What you got, James?
Well, I was first going to ask if you had worked with those kind of systems before and had any success with them. And I was going to share that, before we were talking about like deterministic versus non-deterministic, like interpreted versus compiled languages, right? Mm-hmm. And so even in a compiled language, if you're doing dynamic memory allocation, whether you're doing reference counting or garbage collecting, all of this stuff with memory management, right?
Right.
That's then non-deterministic, right? The memory that's going to be allocated depends on the data that's going to be fed into the program. And so as a result of that, like my experience has been that number one, monitoring doesn't do any good because the data that you get in your test rig is going to be different than the data that it encounters in the real world. So you're seeing a particular, set of memory allocations and deallocations, and you think everything's okay. And then you put your code out in the real world and it freaking bombs because it hit something else. So there's no, like, that isn't a good approach to making the code robust. The way to make the code robust is, like you said, like, don't do things like self-referential memory,
right?
Chains. You run into that one in JSON as well. Like if you try to do a deep copy on a JSON structure that references itself, you're boned.
Yeah.
So that, that's like, that doesn't work. And then the other reason why it doesn't work is because the monitoring code subtly changes the operation of the system in such a way that what it sees is no longer what's actually going to happen in the real world. So the whole thing just doesn't. Yeah,
Yeah, it is problematic, and yeah, you make a good point, especially if you're consuming external data like JSON or HTML or something that's coming from an external source. You can bound it in certain ways and check it, right? Um, but yeah, it can be all bets are off. If you're in that type of environment, I strongly recommend fuzz testing, right? In other words, as part of your testing, especially if this is like commercial or something, right? As part of your test suite, you should be fuzzing all inputs that do not come that come into your environment. And for folks that haven't done this, fuzzing is essentially basically generating random garbage and sending it into your program and making sure it doesn't blow up. That's actually a formal test that you should be doing anytime you're getting anything you do not control from the outside. It should be fuzzed.
I think we could talk for an like
Oh.
professional programmers could talk for a long time on that topic because we've
There
all
are.
been through the grinder on it in the past.
Yep. Yeah, and there's no perfect solution. Yeah, I could do a whole series of talks on that.
That's yeah, exactly.
It's not only what environment are you working in, it's how critical is it if it fails, what's your budget, how much time and money can you spend testing this, because you can never test to 100%, right?
Right.
So you have to make the determination of how much testing is good enough for the level of failure that you're expecting, right? If it's a browser and it crashes, well, that's obnoxious. If it's a rocket and it crashes, that's a much bigger problem. And then we need to have the question of don't send JSON into your rocket, right? Just don't do that.
The other part of this that just absolutely fascinates me, and if anybody has a chance to read the Feynman lectures or listen to recordings of them, one of the things I love about that guy is that he was right up front about like, well, we don't really know. Like, we don't know. Also, I can't explain this to you without explaining 50 other things that are super complicated. And there are these issues that you stumble across, like, don't ask yourself if gravity is a force, because you can spend many hours on that one. And this is one of those. Like, this is one of those things that you stumble across. It seems really simple, and then, oh my God, is it not? The other thing, just really quick, is every once in a while, an intern or an AI or something like that will write some code, and you see the graybeard's face go white when he reads through it, right? and then the problem is they can't say exactly why they don't like the code. It's just, I've been through the grinder on this before. Don't do it this way, right?
Yeah.
So anyway,
experience counts for a lot. Okay. With that comment, we'll move to the next topic that we could rat hole on for the rest of our lives: thread safety and management, which we know even less about.
From the frying pan into the fire.
Exactly. Nope. You teed me up beautifully for this one. Thank you for that lead in. Okay, so we're not going to go as deep on this. Languages vary greatly on support for threads and exactly how those threads are implemented. And I'm going to go even one step further. You can have hardware threads, for instance, in CUDA. You can have software threads. You can have, what do they call it, fibers, where they're lightweight threads. And the other thing that you can start doing is asynchronous programming, which is using one thread to make it look like, basically async programming is using a single thread and state machines to emulate threading. I'm going to quote Feynman here because Feynman's awesome. This is an area we really don't know what we're doing yet, right? A lot of people have a lot of solutions, and a lot of people will say, but threading and managing concurrency and all the aspects that come out of that is a very complicated topic, and there's a lot of research going on, which leads to my first question. Does your project need to be threaded at all? right? My base comment here is, if it doesn't need to be threaded, don't. Keep it simple. Async, some people think it's simpler, some people not. Okay, question 2. If you need to use threads, how extensive do they need to be? Right? Something like a robotics control system probably doesn't need to be threaded. Something like a web server absolutely needs to be threaded, right? So there's both extremes. And then question 3, what is the communication pattern between the threads? Again, something like a robotics control, yeah, you're going to have some communication there, right? You're trying to control a single system. In the case of a web server, no, you got a whole bunch of different processes spun up that are servicing different clients. Probably don't need to communicate too much. I wouldn't say they're not going to communicate at all, but it's not going to be tight communication. Unlike memory management, there really aren't a handful of common solutions in use. There's threading, there's pooling, there's thread pools, there's CUDA, there's Go has its fibers. So there's a handful of tools, but this is an area of active development. Some languages support threads directly. For instance, Go supports threads more directly, and they're not OS threads. They're lightweight fiber threads, so you could have hundreds of thousands of them. And they all work very, very well if that's what you need. They're lightweight. A lot of them just go down to the OS, right? So threads can be quite heavy, and then you get into thread pooling and so forth. The guidance here is to figure out what you need for threading, if at all. Design your threading and communication architecture before you choose your implementation. If you know you need threads for one or another reason, drive the language that you use based on what your threading requirements are. If you need just simple threading, well, C, C++, so forth. Python, by the way, despite it really doesn't do threading, if I remember correctly. It looks like it does, but underneath there's a lock and only one thing runs at a time. So, that kind of, takes that language out of certain use cases. Something like Go is designed for handling multiple clients with hundreds to thousands of threads, where they're all different. Something like CUDA is designed to run thousands to millions. I had one project I was playing with. CUDA is a hardware parallel processing. It requires a GPU. It's designed for running massive numbers of threads in parallel. I think the record I did was 145 million threads in parallel for doing an analysis problem. Because CUDA just handles it for you, it works great, right? It was the right tool for that job. C, straight C, no. Put 145 million threads into your Linux OS, and you're probably not going to have anything running at all, right? So design what you need for threading, then pick your language and tooling. Okay.
Another question.
Yep.
Let's see. Terry James is asking here, when you are allocating portions of code to different cores for load balancing, is that threading?
Maybe. So the question is, when you're allocating different portions of code to different cores for load balancing, is that threading? The answer is, it depends. So there's different ways to do that. One way you can do that is, and I've done both of these, is spin up a different process, right? A whole different process for every task, right? In that case, you are running different threads because you're running different processes, but you're really just parallel processing. And then you're going to lock the you're going to lock the process to a core. Technically, yeah, it's threading. I wouldn't call that multi-threading. If you're spinning up different threads in one process, then yeah, that's threading. If you're running something like async or some of these these lightweight fibers that are emulating threads, you may or may not get the option to lock them to a core because you're really actually just running on one thread, and the language is just making it look like you're running more threads than you really are. So it really depends on what's going on under the covers. Okay. Okay, so kind of to the next group of these characteristics or properties, industry standards and norms. Some industries have de facto standards of what language is used for what. These change over time. They generally do not keep up with advances in language development. A few examples. Scientific computing tends to be done in Fortran, C, or C++, from what I've seen. Believe it or not, Fortran is still out there. If you're in a hardcore scientific computing, you still see Fortran now and then. Aerospace tends to, or used to use Ada. That seems to have faded. They now use C quite a bit. Rust is starting to make pretty good inroads, especially if, we'll talk about this in a minute when we get to formal language definitions. Rust itself does not have a formal language definition, but there is one called Ferrocene, and that's starting to pick up use in aerospace. Aerospace requires a formal language spec to be certified. Finance tends to use C and C++ for high-speed trading. Automotive tends to use C, specifically because of the MISRA C toolsets and linters and so forth. Testing tends to hang out in the Python world. A lot of times these choices are just historical norms. Sometimes you can step outside the norm and establish a new one. Sometimes you can't. Sometimes it's probably best just to go with the norm, especially if you're in a regulated environment. We'll talk about that in a minute. So just as industries have de facto standards, companies and departments of companies have their own de facto standards. So consider that when you're picking a language. If, like this group, were a lot of hobby folks in here. I also did this talk for a Northwest C++ users group, which are more professional developers. So this slide is really if you're working with a company or inside a company. Do you have the staff, or are you willing to rehire and retrain staff to pick up a particular language? Does your company have specific libraries and specific tooling that are geared to using specific languages? Some companies have policies, right? Some companies are now putting policies in place of any new software development will use memory-safe languages, such as Rust is the one that's commonly popping up, but Swift and what's the new one in Android space? I can't think of it off the top of my head. It'll come to me. Anyway, go ahead.
Java is common in Android.
Yeah, Java, but there's another one that's taking over from Java, and I cannot think of it off the top of my head. I haven't played in that space in a while. Not thinking of it in the moment. Anyway, and is there a direction you want the company to be moving, such as adopting memory-safe programming languages, right? Is now the right time to be switching? If you're working with existing code, well, maybe you use the whatever that was written in, not rewrite it. If you're starting a new project, might be a good time to say, hey, is now a good time to switch to a memory-safe language. For this group, community support, it's an extension. I think of it. Oh, you have a question?
Well, Terry was suggesting Kotlin, K-O.
Kotlin, thank you. That's the one I was not thinking of. That was it. Kotlin. Thanks.
Okay.
It's amazing the number of programming languages out there now too. They're growing like weeds again. Okay. Anyway, community support can be considered an extension of company support or vice versa. Questions to be thinking of: how easy is it to hire developers for the language? Or how easy is it to get your friends to help you with your coding project? Do libraries exist to help with the problem being solved? We were just talking about this one in the case of the Arduinos, right, and the sensors. Is there a library for that to help you with your particular sensor? Does tooling exist to help you support the language? How good are they? How expensive? I'm going to tag into that. How well can AI generate code in the language? If you want AI to help you as a coding assistant, there's a reasonable variation in the performance of AI across different programming languages. Essentially, so if you think about how the AIs are trained, essentially what they do is go to GitHub and various public repositories and consume large bodies of code. The AI is then basically regurgitating pieces or fragments of that code. Programming languages such as Python have a lot of code in the public domain, right? Python's a very popular language. Some of that code's well written, some of it's not. But there's a lot of code out there, right? Something like Rust, for instance, it's relatively new and it's not as popular yet. So the AI may have more trouble generating some Rust code. Now, I've actually used coding tools with Rust, and I found that pretty good. Let's go to something like VHDL, right? That's a lot more fringe, right? And it's still specifically for doing hardware. I haven't tried it, but my guess is AI is going to have a lot more trouble automating code for VHDL than it would for Python, for instance. Are you in a regulated environment? So regulated environments can go from stating specific characteristics of a language, like it must have a formal specification. Some languages do, some languages don't. And if you have to go through an external review, FAA, for example, they're used to looking at, if they're going to look at your code, they're used to seeing things in a certain way. Automotive, MISRA C is kind of the standard, right? Stay there. FAA, if you're going to go off the beaten path, you might have to answer a few more questions for your project when it goes to get certified. And then, of course, the direction the industry is moving. Right now, the whole industry is moving to safe programming languages, right? C and C++ are kind of being a bit pushed aside. To the C++ folks, there is safe methods for doing C++. Excuse me, with C++ 11 forward with smart pointers and so forth, and linters to support that. So that's a trade-off you can make there. Depending on the business model of the company you're working for, or maybe starting, not having community support could also be an advantage. I want to point this out because for some of the newer languages, not having a certain characteristic is a business opportunity. So, case in point, I'll pick on Rust here for a moment. Rust does not have a formal language specification. And I cannot think of... Ferris Labs is the company. Took this as an advantage and made Ferrocene, where they take a version of the language and create a specification for it and certify it. And that's a whole business, right? So depending on what you're doing and what your business model is, pick what you need. Let's get into the topic of regulated environments. If you're in a regulated environment, these are typically medical, aerospace, automotive, government, and finance are the big ones. There's probably a few others, but these are the big ones. You're going to have to go through some form of review, or approval, or certification process for your project. Your programming language is going to give you specific advantages and disadvantages of doing that. You need to consider that. Probably not as applicable to this group, but again, just throwing that out there. We talked, basically I'm talking here about aerospace and a formal specification for the language. We've kind of already covered that, so I'll just move on. Portability. How easy is it to port your code from one platform to another? Most languages these days are pretty portable, so this is not as big of an issue as it used to be. It still needs to be considered if you're, if you're looking at porting your code. So a lot of what I do, I tend to go between Windows and Linux quite a bit. So I want good portability between all of my tools across that. I used to include Mac as well, but not as much anymore. But I want everything to go easily between Windows and Linux, so that does constrain a bit what tools and what languages I choose. But there's also Chrome OS, QNX, VxWorks, a whole bunch of others. Do you want your code to run on different types of processors, right? x86, ARM, RISC-V, PowerPC, MIPS. For this group, I think the processor is probably going to be the more interesting. It's pretty common to write some code that runs on your desktop and then port it down to a microcontroller. So in that case, you'll probably want x86 and ARM, or x86 and some other little microcontroller. This isn't as big of a deal as it used to be because compilers for most languages are pretty common. Python runs everywhere. Java runs everywhere. One I didn't actually put on the slide is, do you want it to run in a web browser, WebAssembly, right? So that's another paradigm to think about. One thing to be considering is if you're going to start mixing things, building and linking a library are not always both compatible. So I've run into a couple of cases where I could compile a library, but because of the compilers I was using, I could not then link them together. So while I had what's called FFI, which is Foreign Function Interface, that's a Rust and C++ term, that allows you to call across language boundaries, you also need to be able to link. So sometimes just having the foreign function interface, whatever it happens to be, isn't always enough. There's another one in Java land, and I cannot think of it at the moment. It's the same type of thing. It's a library that allows you to cross the language boundary. Automated tooling. Again, this is somewhat for commercial projects, but depending on how advanced or how sophisticated you are for building your own stuff, this can apply to individuals as well. What automated tooling do you have to support the language? Build systems, continuous integration systems, packaging systems, linters, style checkers, revision control systems, integration with ticket systems. That's mostly for regulated environments. You've got to trace all your work. Editor support. Autocomplete with AI assistance is now a big deal. VS Code, I've actually found, is kind of the de facto standard for a lot of that if you're not going to do something like Cursor or one of the paid solutions. Some languages are kind of build your own. C and C++ are very much build your own for all of this. Python, with the Anaconda development chain, kind of comes pre-packaged for you, or you can build your own. Rust, for instance, comes with your build system and your linters, and your packaging system is all in a tool called Cargo, including your style checker. So depending on the language, sometimes you get these things for free, sometimes you have to build your own. One thing I do want to note, text-based programming languages have a good common level of support across a lot of this. Especially revision control systems and code management systems. Graphical programming languages do not. And here I'm specifically pointing at LabVIEW. If you're going to run into a program that uses LabVIEW or any of the graphical type tools, and there's a couple of them out there, and you're going to use a revision control system like Git, you will run into problems with that pairing. It can be done, but just recognize it doesn't work smoothly. For those of you who are into this, just think of doing a diff merge of a picture. right? Essentially, your graphical language is like a picture. It's a binary representation. You do a diff merge, and you're not going to get anything meaningful out of that, right? The diff merge is primarily a text-based operation. Okay, execution environments. Let's see. Okay, I'm going to speed up a bit. Execution environments. You may have different development or testing or deployment environments, right? So again, this is mostly focused on professional and commercial systems. But in an embedded system, you may have a simulation or emulation being used for your hardware. You may have different testing environments. For large-scale development, you're going to test locally and deploy to some production environment, which is a data center, for instance. So you need to think about how that language transition and compile and workflow happens across the whole thing, from specification to development to testing to deployment. Multiple languages. So we just talked about a whole bunch of different language features, right? I'm going to go one step further. My slide says very common for a language to be implemented in multiple programming languages. It's almost typical. I haven't done a project, even a personal project, in probably 10 years that's been restricted to just one language, right? You end up using a set of languages, and to each one doing its own particular thing. So, for instance, a trivial project may have C++ as the primary language. Then you're going to use CMake as your build system, because C++ doesn't have a natural build system to it, but CMake works pretty well. And excuse me, if you're going to talk to a database, you're going to have SQL embedded in your C++, right? So you're really using three languages. Think about how that works and how you need to manage it. If you're running a team, you need to think about, do you have support for these different languages across teams? One thing that I will say AI is really good for is if something like, CMake, right? I use CMake occasionally, but I don't use it day to day. And when I do, it's fairly simple. I ran into something where I needed to do something moderately complex with CMake. Didn't happen to have a coworker that was a deep expert in it. It was a simple one-off task, right? It was fairly tricky what I needed to do with. It was involving CUDA and cross compilation of CUDA, which is so it was, but it wasn't that hard to describe. I just went to, I think it was ChatGPT, and said, "Hey, here's what I need to do. Make me create a CMake file," and it did it, and it got it pretty darn close on the first shot. So, if you do have some small gaps like that, AI is wonderful at filling those in. Okay, so in summary, choosing the programming language for the project it's not given enough thought or time. This can lead to increased development time or actually even project failures because of incompatibilities between language and project requirements. I've actually done this in the past for a project. Set up a little spreadsheet like I've got below. Figure out what aspects are important to your project. You can weight them if you want. And then just go down the list of languages, right? And we actually did this, and it was a very, very good exercise. Hey, I need these particular sets of properties. How is it supported in this language? And by the time you get done doing this exercise of evaluating the different languages, you're going to have one or two languages that are going to be, hey, these are going to probably be better. And off you go. Okay, we're a little bit over. We've had a few questions. We've probably got time for a few more, but what do we got?
Let's see.
I'll stop sharing real quick here too.
I really like that idea of having a little matrix on the spreadsheet and figuring that out. Wouldn't it be possible to sort of pre-fill that for most common cases?
Yes. Yeah. And again, if you're working in a
And
domain,
have you done that? And why didn't you share it?
okay, the reason I didn't share it is because the group I was working for was in aerospace and it was proprietary, so I can't. How's that for a disclaimer? I'm claiming an NDA. I'm going to go one step further. For things you do commonly, like, we're doing robotics and so forth, you get a handful of choices. Like, if you're going to work with Arduino, for instance, we'll pick on that one. You're using Arduino C, right? You just your tooling kind of dictates this. So, you can take the harder route, but it's, if you're familiar with it, there's usually a pretty good choice. Depending on exactly what you have to do, I don't think there are standard templates for this, because for each person, each project, each team, the weights are going to be different, right? I know certain programming languages, C, C++, Rust are kind of my go-tos. You know, I do a little bit of Python, but not much. But for instance, I use Jupyter Notebook, which is it's a live notebook. Even though Python's not my native language, it's the right choice for using Jupyter. So when I'm in that space, I just kind of have to get pushed into that domain. And for each person, each project, each tool set you're using, I think you're going to have different answers, and that's kind of the whole point of this talk, right? Here's some tools to figure out what's the right solution for you.
Yeah, I think you could argue though that, like, I don't know. Well, no, I was just about to say that you could argue that C is not memory safe, but you can write C that is safe
Yeah,
for memory. So, I mean, using dynamic memory, I mean, you can write C that does correctly use dynamic memory. So really,
yes.
I guess what it comes down to is the spreadsheet idea is more of a, like, how hard is it going to be to do this right in this language?
Exactly.
And then probably within this particular project. Okay, I'm coming around to your point of view here. I think you're right on that.
Oh my gosh, I convinced somebody of something. Okay, in
Make a
the
note.
meeting now, before we get any more.
It's a great talk, by the way.
Thank you. Yeah, it came out of, like I mentioned, it came out of a college course that I had that I have not seen replicated. And essentially the college course I didn't get into this when I talked about it earlier, but essentially what the college course did is deconstructed most of the popular programming languages at the time. Fortran, Basic, I'll date you right there. Fortran, Basic, C. I don't remember if we included C++. We had Simula, which was the object-oriented. And basically deconstructed those programming languages into feature sets and how those features were implemented under the hood, and then compared and contrasted the different languages against each other. It was a wonderful course. Anyway, Terry, you got a hand up.
Yes, I had a couple of questions that I threw into chat, but the chat stream has been moving on, and I was just curious because I've been doing work in around Python. I won't say in Python this year, in a sense. It's somebody else's code, but I was wondering if anybody has used NI's new AI for LabVIEW that's called Nigel, and well, yeah, just curious because and asking questions of even the NI guys, it seems like Nigel doesn't allow you for free to protect your code. If you're using the AI, it's put out on their open server, or through their server connection. And when I asked, about that, they said, yeah, there's you don't have a way of making it private right now or whatever. And I was like, well, then why would I ever use it for work? And this is all people coming in from work. This is a LabVIEW user group meeting where they're all doing proprietary code. I'm like, this seems nuts to me. Why would you offer it then?
That scares the living hell out of me for two reasons. One,
yeah,
I'm just going to go take one step further on that.
Yeah.
One is proprietary code based on company standards, right? That's one layer of that.
Yeah.
However, if you've ever worked in aerospace comes under ITAR.
Right? Yes. Yeah, and I have. Yeah.
In the case of ITAR, you're not just violating company policy to do that. You're violating federal law.
Yeah.
Yeah. Very serious federal law.
Very serious federal laws, right? So it's not just you're going to get fired. You can go to jail.
Yeah. Yeah. Bad jail, federal prison. Not fun.
Anybody listening to this, if you're working in regulated spaces, especially ITAR, do not put your code into public AIs, right?
Yeah.
Now, what you can do, and I actually do this just myself, and we could probably do a talk on this. There's Olama and LM Studio that lets you run AI models locally. They're completely detached and secure, and you can do that, right? So there are ways to do it. But yeah, do not put your code into public. Even if they say, you got a subscription and they say, we're going to keep this private for you. No.
Yeah. Yeah.
Especially under ITAR.
You were mentioning, you were talking about using Arduino C with Arduino, but I've dealt with a few robotics applications where they'll allow you to flip over into Python and use Python on Arduino. Are there downsides to using Python on Arduino, and is MicroPython more preferable for something like Arduino or not?
I have not done Python on Arduino. I don't do a ton of Arduino. The only thing I would say, the obvious downside I can see is performance if the Python's interpreted.
Yeah.
That's the one I could see. Anybody else got some thoughts on that? That's not something I've done a whole lot of.
When you're talking about that, I think the vast majority of those systems are actually MicroPython, which is kind of a subset of Python, or like a different version of Python, which is specifically designed to be more performant on microcontrollers. And also, what's considered a microcontroller these days is what we would consider like a full mainframe not that many years ago, right? So
it's really changed.
That's not as bad as you might think. The experience that I've had with it is a thing called OpenMVCam, which is a little web camera with a processor on board that allows you to do things like blob detection, color tracking, like simple vision system type stuff. And the biggest problem that I had with that was really the memory constraints on the particular processor that they were using. What's happening with Python 90% of the time is it's no OpenMVCam is the thing, Terry.
Thank you.
They're pretty cool little units. I like them, but they can be very frustrating. What I was going to say is most of the time, and this is what Bob was pointing out before, which I think is a really good point, is it's not Python, it's Python plus something else, right? Like it's Python that's scripting very, very well-written C++ or C code, right? So as long as you're not trying to, like if you're doing a vision system and you try to use Python to look at individual pixels and do something, you're dead, right? But if you use Python to call C++ routines that are doing processing on like a whole frame at a time, or over multiple frames or something like that, then you're probably going to be fine. It's just a matter of the right application.
And the answer also depends on your specific device. Not every device, every microcontroller will support CircuitPython or MicroPython. Some do, some don't. And so you've really got to, depending on your device, make that decision.
I
Yeah,
love your
the-
image there, Craig. That car is cool. You have to do a presentation on that at some point in time.
I can do that if you'd like.
I would love to see
Yeah.
that, but only if you make it jump over something like in Dukes of Hazzard.
I've got
Sorry.
video of it running on a slot car track.
Awesome.
Does anybody know what the key differences are between Python and MicroPython? I mean, what's this? How I don't really this. I only know them by name. I don't really understand the significance between the two.
That's
The
a really good
biggest
question.
difference
I don't know.
The biggest difference is in the diversity of the capabilities. Python gives you access to the full stack, and then Circuit Python is a very limited stack built specifically for microcontrollers, and then MicroPython, very similar to Circuit Python. Which one is more limited, Micro or Circuit Python? I'm not sure, but its capabilities and the breadth of those capabilities.
I think the other big one that I've seen is that MicroPython is optimized for low memory use, and regular Python, you can't even get it to run, and the amount of RAM on a PyPico or something is just not going to really happen.
Okay.
My experience has
Thank you.
been that when I'm working with microcontrollers, it's usually because I have a time crunch and everything has to be fast. So Python wouldn't work at all.
Okay.
It's interesting because there is a compiled Python, CPython.
Yep.
And I've always been kind of curious to play around with that, but I haven't. Has anybody played with compiled Python and maybe tried to use it on I don't know if you even can target like a PyPico or a ESP32 with it.
Yeah, I haven't played with it on an embedded environment. We did look at it for it was another project that we were doing. The interesting thing is it's compiled. Yes, it provides definite performance benefits over
Regular Python.
regular Python, interpreted Python.
Right.
The interesting thing, though, is for Python to work and to support the full Python architecture, a full Python language, because Python is natively interpreted, the language itself makes assumptions about what can change at runtime, right? There's everything is dynamic in Python, right? You can override libraries, you can override operators, you can objects can take the place of other objects. You can pass things by name, right? So symbolic binding versus or a language, a named binding. Many of those features, reflection. Let me just throw that one in because that's a really big one. Many of those features require dynamicism at runtime. So if you're going to support those or use those particular features with a compiled version of Python, what's going to happen under the covers is you're going to a runtime library that is basically still doing some level of interpretive work at runtime, right? So you need to think about that one. Just like we were just talking, where you take Python and use it to glue together compiled code. The other is also possible, right? You take compiled code and use it to glue together interpreted code, right?
Yeah. That's a really good point. You know what this reminds me of, because I'm old as frig, is back when C compilers first started coming out for microcontrollers, like for PIC, right? And there was a lot of times where you would write something in C and the compiler would just do a really bad job of making assembly out of it. And so in your C code, you would drop to assembly and optimize a particular part of it. So now I feel like the issue that we have in Python is that you really have to switch development environments in order to write your compiled, C++ code for your library and then stitch together for Python. So what I want is one IDE where I can write Python, but then drop to C++ inside the Python IDE. And then in the C++ code, if I need to, I can drop to assembly.
So okay, you run into the same. Yeah, I can talk to that one. I haven't done that exact pattern, but philosophically, I'm a really big fan, and this is not necessarily even guidance, right? It's just my philosophy. Is I want one tool that I can use everywhere. And of course it's hard to find these things. Orange jumper, yeah, okay. Essentially, it drives me a little bit nuts because I know the internal architecture of VS Code, and it drives me insane what they did there. But it's the later incarnations of VS Code, I have had wonderful success. Excuse me, running it both on Windows and Linux, which are my development environments, and mixing and matching languages with the plugins. So in particular with VS Code, I have it tied into my local AI, which is LM Studio. I can go in and edit my Jupyter notebooks natively with the plugin for Jupyter, which includes Python code. I have successfully mixed and matched C and Rust code, and it just works. The one thing I will say about VS Code, it is not the most efficient thing under the sun. The way it's actually written and this was a serious joke running around the industry for a while. And I understand why they did it. I just wish they didn't. I'm VS Code free version is what I'm talking about. There isn't a licensed version that I'm aware of for VS Code. There is a open source version. But
I've seen adverts for a professional licensed version of VS Code.
Oh, there are
where they charge you for it. Yeah, that's why I asked.
That's creepy. Okay, I should go look at that.
Yeah.
But it's written in C++, then compiled to WebAssembly, which runs in is it Chromium? I think it was the Chromium browser extension with the V8 engine, which is then written in C++. And there was a C++ podcast that made all kinds of fun about this a couple of years back. So basically, you're writing in C++, translating it through a whole bunch of different layers, interpreting it, and eventually getting it back to C++. And you do take a performance hit for that. And I actually stayed away from it for a while because the performance was actually quite poor compared to Sublime, which is what I was using. The latest incarnations, even with a fair number of plugins and going out and grabbing references to a local LLM and so forth, it's reasonable. So if you want, and by the way, if folks are looking for a newer editor that's got really good performance, one of my friends was introducing me to the Zed editor, Z-E-D. Great performance. It's fairly new and it's completely written in Rust. So that's an interesting editor as well. Okay, other questions, topics. We're at about 12:30 here, so.
Well, I don't want to forget to just say thank you. This has been incredibly informative, and a bit of it has been way over my head, but but it's adding to my library of terms that I can sort of react to, maybe not respond to, but I really appreciate it. It helps fill in a lot of gaps I have.
Thank you.
Yeah.
I really think that this kind of high level overview of like how to approach things is going to become like more and more valuable because more and more the AI is just going to do the programming. It's a matter of us like providing the overall guidance for it.
Yeah.
I've been blown away working with Gemini Pro more and more how good it is really on programming. It takes me longer to write the spec for a complex web page than it does for Gemini to spit out a perfectly working page in one shot. So
Yeah.
I'm amazed by it. And I think our experience has to be targeted towards this like overall understanding of things as opposed to getting into the details, because those are gone.
Yep.
Does anybody have feedback on Claude code? Because I'd heard Claude was supposed to be the version of Claude that's for programming is supposed to be getting better too.
I haven't used it a ton. The objection that I have to it is that, as far as I understand it, it costs like, I don't know, it's $20 a month or something. And
Yeah.
That's
you
one
can
of the
get access to Gemini for free if you have a Gmail account. And the free access to Gemini, I think you get like 20 requests a month or something like that at the pro level. And then you can get like multiple, you can just go to Google and just put in a prompt for it to write code, and the stupid thing will write code right there in the Google output. So I would say, like, before you invest in it, just try some of the free ones first.
Yeah.
Oh yeah, no, I think I mentioned this in a previous meeting that I got a chance to see a gentleman do a project, and he was bouncing back and forth between Claude Code and Gemini, and Claude Code had a problem that it couldn't identify, and Gemini fixed it. But he was using both paid services in both cases. One was a monthly, and the Gemini was by token.
Right.
Unfortunately, he was paying for his services he was using, but he used so much of the Claude code that he used up all of his memory, and didn't finish the project without wiping out the memory. And so he had taken special measures to be able to make sure everything got saved down on his local computer in code libraries and in documenting the code and data sheets even, and then so that he could do that. He could just wipe out the memory space that the AI was using and start over, or not start over, but continue on after he had used up all of his allocated space.
Yeah.
I've been bouncing between the free versions of Gemini and ChatGPT, and I've run into some daily limits on ChatGPT, and never have once run into a limit with Gemini. And really, I've been more impressed with the results of Gemini than I have been with ChatGPT.
Yeah, that's been my experience as well. So what I was talking about with the cost of Gemini is they give you a certain number of like pro accesses on the free subscription. If you just stay with Gemini free, it's just free, period.
Is there, I'm sorry, am I hearing a name difference? Did you say Gemini Pro and then Gemini?
Gemini Pro is at like a different level of Gemini, right? So there's like if you just go to Google and if you're signed in as a Google user and you do or search or something,
yeah,
it'll give you a response. That's the Gemini free, and you can go into, I think they call it AI mode or something like that. And you can just have a full on conversation. It'll write code for you all day long, forever. But if you go to Gemini if you go to gemini.google.com, then there's access to multiple different levels of Gemini, and you get a certain number of accesses to Gemini Pro per month through that interface. And then it's $20 a month. It's the same cost as Claude to get access to Gemini Pro, and Gemini Pro just rocks. I'm totally blown away by it.
So, on this topic, I put a link in the chat window to a book called Vibe Coding.
Cool.
Yeah, so this is very much on the topic we were just talking about. The book is written by the CEO and co-founder of Anthropic, so it's frankly a little biased toward Anthropic and Claude. But it in all honesty, it's a very fair book. I wouldn't say it's the best book I've ever read, although it is absolutely worth reading. And it talks about the main thing it talks about is the mindset that you need to go through to productively use AI as a coding agent, right? And he uses a kitchen analogy, or professional kitchen analogy, where you're going from the cooks to being the head chef. right?
Right.
And the AIs are becoming your cooks. If folks are interested in that, I've thrown it into the website. It's well worth reading. It's not a super heavy read, but there's very good information in there. He also gets into topics of how, if you're going to do coding with agentic coding, where that's directly editing your code and so forth, how you need to set up your branching and repository strategies to keep from having a nightmare. He does get into techniques on how and why, where the coding goes bad and how to deal with it. And he finishes off the book with managing teams of AI agents. And to the cost aspect, now keep in mind, this is the guy, the CEO and co-founder of Anthropic, right? So he has access to a lot of computing resources. There's one statement in the book where he turned it loose on a project, and the estimated cost per year was $400,000 in tokens, right? So, you can run up a big bill with this stuff, but, anyway, it's, that's a reference for folks on that topic.
The system or the way that I think about it is as if it were an intern. Like, okay, what's the old story about, like, show me an intern that only triples my workload? So, but there's this mythical intern that doesn't actually exist who actually helps, right? So I think about it like a mythical intern, right? And one that's.
I'm not saying anything to that because I probably got an intern that I've had watching this.
Exactly. I just to be clear, I have learned a lot from interns.
Oh yeah, interns are great. I love it.
Yeah, I'm not trying to diss interns.
But I will state, now I'll go on record as stating this. If you're working with an intern, the primary benefit is to the intern. The primary benefit to you is someday in the future hoping you get an intern that has been properly trained and turned into a full-time employee.
Yes.
Right?
Now right. You're investing in the future, not
that's right. That's the way you view this.
but this so the way to think about the AI is if it's an intern that's actually pretty good, right?
Yes.
And that was last year's approach. This year's approach is it's a coworker who, when I'm stuck on something or when I don't want to do something, it's like, oh, hey, can you help me out with this? And it's probably as good as I am now. At least, well, Gemini Pro, because I have access to Gemini Pro through my work, and it just absolutely rocks. Now, having said that, it will make mistakes and do things that don't actually apply to the project in a good way, and it'll build architectures that aren't expandable, and it's not perfect, right? So I still have a tiny little bit of value as a senior experienced programmer.
Yeah,
that'll be wiped out next year.
I turned the AI loose on building unit tests for one of the functions I wrote, right? And it was a fairly involved function, and it was a key function to the application, right? So this was a key algorithm that I needed to know performed properly. And I said, it was a test. I wasn't doing this to, in place of production code. So I was keeping an eye on it really tightly, right? Like read every line of code it wrote. And essentially what it did is for the unit tests, it copied the algorithm into the unit test and then verified that the unit test and the production code gave the same answer. Which, if you stop and think about it, is a complete no-no because it copied the production algorithm into the unit test. So it was testing, does A equal A?
Right.
Right?
Yeah.
Was it 100% good, or did it have
all the unit tests passed? Wrote, and to be honest, it did a good job of covering edge cases and so forth, right?
Mm-hmm.
So if you just looked at it on the surface, The test passed. It had a good number of unit tests that covered all the edge cases and dimensionality of the
right.
algorithm to be tested.
Right.
The key mistake it made is if there was any error in the production code, it copied it into the unit test and would completely blind to any of those errors. Right?
Yeah. Yeah. But tell me, haven't you ever had an intern that would have done that?
Oh, no. I'm going to go one step further. And to the person watching, if you're listening, my apologies. I won't name names. I had a young FTE do exactly the same thing, and not blatantly, but in principle did exactly the same thing.
So you don't have to imagine it; you've experienced it.
I've experienced it, and frankly, and this was in aerospace, and the person was not super familiar with aerospace at the time, right? This was and my job as the lead was to make sure these types of things didn't happen and help coach people into this. So it was a learning environment. So I don't fault the person at all for doing it, right? But a human will do the same thing if they don't fully understand the context of what they're working in. Right. And that's it's a learning, and I'm going to go one step further. I've done stupid things like that too, right?
Oh yeah, that's one of the things I have to say is there has been, I don't know, 3 or 4 times now where I've taken some code that I've written and uploaded it to Gemini Pro and said, hey, I need you to add this to this or refactor this so it works in a slightly different way. And what I always do is I take the code that it generates it and I put it into I do a diff on it and look at like what exactly did it change, right? I always review the code before I commit it. And it changed code that I didn't ask it to change. And I went back and asked it like, well, wait a minute, you went and changed this code. Why did you do that? Oh, and it would answer like, well, that's bad practice because da 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 da. And I'd be like, what? I go and look it up and think about it and go, oh, wait, it's right. This is better. And I was making a mistake.
Yeah, I've had that in both cases as well, where it's gotten that right and where it's hallucinated. And I'll go into the third case where, yes, what you did is appropriate in some cases and not appropriate for this case, right?
Right.
So it's a tool, right? Use the tool for what it's good for. Don't use the tool for what it's not good for.
Yeah.
And just like a young developer, and frankly, we were all young developers at some point, right? Keep an eye on it because we've all made silly, stupid mistakes, and it's at the stage where it's going to make silly, stupid mistakes, and 40 years from now, it won't.
Right.
Has anybody been using interfacing with AI using an audible conversation as opposed to written prompts out of curiosity?
Not much. I've tried it. The mode I'm generally working in is more text-based anyway. So,
I actually have, and I've had, so in the context that I have a tendency to run out the door late for an appointment and tell my phone, I used to be able to say, hey, name which cannot be uttered, navigate me to my next appointment, right? And have it like just freaking do it perfectly every time, no problem. And then they upgraded and put Gemini on the stupid thing. And now it's like half the time it does it right, and half the time I find out that I'm off to some other address that sounded the same, or why did you do that, right? So I think there's places where it's a bad idea.
I've been noticing that with the Apple product, name it cannot be stated, as well, that honestly I feel like in the last 3 to 5 years the AI voice recognition has actually gotten a lot worse over time. I deal with a lot more mistakes when I try to do that very thing, do navigation or ask it for contacts out of my own address book. and it misinterprets what I'm saying. And when it reads back to me what it picked, I'm like, I didn't say anything near the phonemes for that name that you found. And it was like, what did you hear? It just really strange. And it's frustrating because it used to be more accurate. I could swear Apple was a lot better in the beginning, and now it's just kind of gone in the
They've
dumpster.
added this extra layer of quote creativity end quote over the top of the actual just like text to speech, or sorry, speech recognition.
Yeah.
I think some of
Yeah,
that's paid advertising too. I've run into the same thing with Google Maps, searching for West Marine, and it led me to a competitor.
Oh,
yeah. They did that with my dentist the other day.
Yeah.
Yeah, I think it has more to do with the AI that's behind it than the actual speech recognition.
Oh, sure. That could very well be. I'd kind of, if I had a choice, then I would kind of say, can I turn that off? Because I liked the old version where it wasn't smart. Put that in quotes. Yeah. But anyway, yeah.
I know this could go on all afternoon. I know you guys are like, this sounds like we need to have a discussion just about this.
I think you found your main topic, Steve.
Yeah, I think so. Okay. So just really quick on this one here. So next Saturday will be the Building with Arduino. So anybody wants to join up with that. And I was thinking about maybe serial communication might be a good video topic for next month. The guy we watched today, he has a video on just that topic. It's like 11 minutes. So I'm thinking about that one. So I'll watch the video and see if it seems reasonable. But so anyway, yeah, thank you all for joining us, and this has been fun. I will be back in Idaho next month, so but I will be should be able to host the meeting. But I think Lloyd will be hosting it in April because I will be in Texas at a conference. So anyway, thank you all, and have a great rest of your day, and see you next month.
Quick question before you guys bug out of here. On the main website, the calendar just shows that there will be a meeting, but it doesn't show what the topic of that particular meeting will be. Is there a list somewhere, or just what is next month's topic?
Let's see. Next month is going to be a facilitated discussion.
Okay.
So, it probably, as a matter of fact, it isn't in the calendar yet. So it usually takes about 2 days or so for the calendar to update on the website. So yeah, I'll get that in there, and it'll show up the facilitated discussion, and then the Lloyd will be doing the next one after that, and then we'll see what happens in May. So
I'll show you some of the code that Gemini has written for me.
That could be cool.
That could be very interesting.
Yeah.
All right.
Yeah.
So, have a good day, guys.
Thanks, folks.
You too.
Cheers.
Thank
Thanks,
you.
everyone.
Thank you,
Bye.
Lloyd. Steve.
Yep. Okay. Go ahead. That.